Well, good afternoon to everybody. Welcome to this session. So, in this session, we will learn from our speakers how to do this interconnection between continents. I think that people that work in this area are mostly of the time working in the background, doing silent work that most of the end users do not know that they are solving problems, sometimes very complex ones, in order to make all these long distance spaces become short distances. So we'll start with a presentation by Dale Finkelson and Carlos Garcia. Dave has been with Internet 2 for 6 years, and prior to that he was in Nebraska University for 24 years, and currently is primarily focused on international engineering and related activities.
Thank you. Hi. So I'm going to talk about a facility that we're working with Ankabut and NYU building in the Middle East, and just give you a little overview of what it is. And a colleague of mine, Carlos Garcia from NYU, is going to kind of discuss a little bit why NYU is, as a university, NYU, by the way, stands for New York University, for those of you not conversant with U.S. universities. He'll give you a little overview of what their goal and reasons here are. So, as I said, we've been working with NYU and with Ankabut. Ankabut is the NREN in the UAE, for those of you who are not aware of that. We've been spending a lot of time, really probably a year and a half or so, discussing how we can improve overall the global connectivity out of the Middle East, and I think we've come up with a design based. There's been a working group that has been meeting basically once a week for a very long time. Working through both the technical details of how we do this, the organizational details of how we do this, and we finally come up with a design, and we are very much in the process of implementing as we speak an open exchange point in the Gulf region. Specifically, this facility will be called AGEOX, which is Arabian Open Exchange. And it will be located in a facility in Fujairah, the UAE. Fujairah, for those of you who are not aware, is basically a cable landing location along the coast in the UAE. It's a hub for an amazing number of cables that come both from the south, the east, and the west. It is a very natural place to put a facility such as this. And as a result, that's why we are locating it at that point. Just as a kind of a level set, I thought I would just spend one slide just giving you a sense of what an exchange point, why we're calling this an exchange point as opposed to just a place where we connect Ankabut or any other NRENs and such. You know, there's been a lot of work over the past several years on developing making an attempt to develop a rational approach to global networking, as opposed to having lots of individual NRENs just picking and choosing where they're going to buy circuits to for their own purposes, trying to come up with something that's a little more unified, a little more effective, a little more cost-effective for everybody involved. And hopefully that leverages the ability of lots of individual NRENs to conjoin and build something that is of value to not only them, but to lots of other people as well. This architecture tends to coalesce around what we call exchange points or open exchange points. These are facilities that typically are operated at layer 2 or some variation of that. They're essentially meet points where aggregation can take place, and then you can bring higher capacity circuits out to other exchange points. And by the time you build sort of an interconnected mesh of these around the world, you end up with a far more effective approach to being able to move the kind of traffic our user community is interested in from one location to another, and let them collaborate in the ways that they really want to collaborate, and hopefully become more effective at the work that they are actually interested in doing. You know, these exchanges, we hope, will eventually grow into things, into locations where we have advanced capabilities, where we can start pushing the envelope on both the technical and the organizational capabilities of any particular site or region. Certainly the work that we're doing with AGOX is very much an attempt to kind of you know, push the level of development in that part of the world and get them far more richly connected to the rest of the internet, the RNE internet as we understand it, and hopefully be able to provide their universities and ours much more of an ability to do advanced services within this region. Other examples, just in case you're wanting to know, of these kinds of exchanges would be Manlan and Wix in the United States. Wix is in Washington, D.C. Netherlight and Géant Open in Europe, the exchange that's in place in Singapore. And we do, in fact, really regard the development and deployment, and that's really the key here, is deploying these facilities. It's not just thinking up what the right plans for them are, but deploying facilities that are functional and workable and useful in the region to really help extend these architectures and extend the capabilities out to a much broader variety of individuals. I have another slide here just that talks about some of the potential principles that you might decide. I'm not going to go through all this now. It's just there as a reference point, and people can look at it later if they want. So this is basically what's happening. In case you're curious where Fujairah is, it sits out right on the Gulf of Oman. There is internal connectivity from Ankabut to Dubai and Abu Dhabi. I don't know that that's really fully representative of the Ankabut connectivity, but it is certainly all there. You can see where some of the other Gulf states sit in this. The intent initially is to create a path back to Singapore, where we maintain a data facility that is being used largely by some U.S. universities that have interests in the region, as well as being able to connect to Singarin and all of the wonderful peers and organizations that Singarin brings to the exchange point in Singapore. So that's, and you know, one hopes, and certainly there's work being done to try to understand how we can find some partners and work with some other organizations to create a path back to Europe as well. If we were to do that, by the way, once we get that path to Europe, in fact, done, and I have every confidence in the world we will get that done, I just don't know exactly when, there will in fact be a path around the world that will go from the west coast of the US to Singapore, to Fujairah, to wherever we happen to land us in Europe. Could be Amsterdam, could be London, could be Paris, could be a number of places, and then back to the east coast of the US. That will be available for RNE traffic to, you know, so if you're really interested in running a long distance stream, we could probably find a fairly long distance for you to run it at. But I think that would be just a wonderful accomplishment, and we could not have accomplished this without the help of our colleagues at Ankabut in terms of being able to work through all the details of getting a facility built in that part of the region. So we're enormously thankful to them for their help in putting that together. Just to bring you completely up to date, the hardware has been obtained. It's currently in process of being installed in Iraq, in the location at Fujairah. This will be operated by Ankabut, and will be available to any comers that want to participate in this exchange point. As far as the circuit, it is a 2.5 gig circuit to start. It is not only on order. I am told in an email earlier today, would you please test this? We've been asking you this for a couple days now. Would you mind getting around to it? And my response is, sorry, I'm busy right now. I'll do it next week when I get back to my office. But I have every confidence that we will have this in place and operational right around July 1st, give or take a few days. Could be a little bit longer, could be a little bit less. We should be able to put traffic on it certainly yet this summer, and hopefully fairly soon yet this summer. So moving forward, AJOX is very strategically located to provide service to and connectivity to a great many NRENs. As I said, there are many cable systems that come up from Africa that come into Fujairah that would be certainly capable of bringing circuits into this location. There's cable systems that come from India. There are multiple cable systems that come from various places in Southeast Asia, and there are certainly multiple cable systems that go from Fujairah back into Europe. So it's a very strategic location, and one of the key features of building these exchange points is that, in fact, you find these strategic locations to put them at, because that is so often the key to making them successful. And if you don't find locations like that, then you have to work extra hard in order to make them be useful. But I don't think that's going to be the case in this one, because it is, in fact, a very, very wonderful location for putting this sort of facility. So that's basically all I was going to say about that. To follow next, I was going to ask my colleague from New York University, Carlos Garcia, to just explain a little bit about why a university like NYU or some of its comparable universities is interested in having facilities in these parts of the world, and why it's important to them, and why they're so willing to be an active participant in building and working these kinds of facilities. So Carlos, let's see, you're going to use this. Let me just see if I can tap here, actually. Yeah.
Okay, good afternoon, everybody, and thanks, Dale, for the leadership you've provided us at Internet 2 throughout this project. So as many of you may know, NYU has evolved somewhat rapidly over the last 5 years as a global university. So we're currently on 6 continents. We're operating 13 standalone study abroad facilities, and we now have 3 degree-granting campuses located around the world. New York, as you know, has been around for a little while, but we launched recently in Abu Dhabi in the UAE, and also in Shanghai. We've relied for years on partnerships with the global NRENs to interconnect our sites, both for teaching and learning and research. And with the launch of these new degree-granting campuses, research activity within NYU obviously is becoming more global, and surprise, surprise, across our global campuses, the community is indicating to us that it wishes to collaborate with other research universities in the regions that we are now newly in, not just with the NYU schools and sites. And so we started to talk about this with Internet 2, and then with Ankabut, and with others. And a global community of interest really began to coalesce, with universities and NRENs joining a dialogue about how to address similar goals. So Dale mentioned ManLAN earlier, which you see lassoed here at the left. ManLAN was really a shining example for us. The collection of carriers and partners present here is so compelling. We've actually co-located our enterprise data center for NYU in the same building in which ManLAN is located. And we started to ask, how could we build on this model and extend it to other regions where NYU and its peers are already doing interesting things? So as I said, this became the discussion with Internet 2, with other US universities, with NRENs. We started exploring a Far East exchange and co-location facility, which Dale referred to earlier. And then with Internet 2 and Duke and others, we were able to bring a better economy of scale to that site, both for connectivity and co-location. From an NYU perspective, we're enhancing the services that we provide regionally, making them more survivable in the region. We're also pursuing improved access to public cloud providers. On top of that, it's plain to see we're now getting close to having that ring around the world that Dale alluded to. And that focused our attention back on the Middle East. So these are some of the use cases that NYU has in Abu Dhabi for developing interregion and inter-university connectivity. And there's a little bit more information about these in an appendix on the slides online. I want to call out a footnote at the bottom here as well. It refers to the evolving teaching and models that NYU is working with. And those involve connecting our students and faculty across our global campuses for two reasons, both real-time pedagogical experiences as well as asynchronous curricular programming. And so on the backdrop of all this, why are the exchanges interesting to NYU? The question that Dale posed. Obviously mission. We want to enable the use cases like the ones you just saw. Economics. It happens that one of the largest technology operating components budgetarily for our sites is actually connectivity. So we want to create economies of scale, increase competition, make all of this more affordable and sustainable for the university. Public cloud services, actually, I mentioned earlier, are another important factor. No longer do our communities rely solely on the services that are provided from within the university to do their work. So we want to provide those improved and enhanced connections to public cloud providers that they depend on. And then, of course, back to the NYU services, the exchanges create opportunities for improved availability of our services within a region. So things for NYU like DNS, Active Directory, we use the DMVPN protocol to secure communications between our sites. If we can locate those services additionally in other regions through these exchanges, in the case of regional breakdowns of connectivity and things like that, a site loses connectivity back to New York City, they stay online and they stay able to communicate with the other NYU sites, and perhaps even going the other way around the world, back to New York still. And of diversity, and this is really important for the Fujairah case. This exchange creates regional geographic diversity, opening up alternative paths and better assuring reliable connections between NYU sites and also those other research institutions across the globe. So in summary, locally, the exchanges promote competitive choice. They foster in-country and regional partnerships. And if we can complete that global research ring, provide cost-effective connectivity between regions. In our case, for this project, Middle East and Far East was very important. At NYU, we're looking forward to having ever more NRENs and universities participate in the exchanges as they grow and mature. And as research activity in these regions continues to increase and create new institutional partnerships, we expect that the value of these exchanges will only go up. So that's the NYU perspective on exchanges and this particular project in Fujairah. I want to thank Dale and Internet 2 again for providing us with the leadership and relationship management in these activities, and of course Fahem and the crew at Ankabut for enabling this project and for operating the exchange. I'd also like to take this opportunity to thank the global NREN community, especially across Europe. I'm not sure whether NYU has been represented at this conference before, but we've partnered with NRENs in Europe and elsewhere around the globe since about 2002, and they've been great partners all the way back to then. It's been a priority of ours to engage in that community, and you've been very welcoming, so thanks for that.
Thank you for this presentation. Now I would like, we have time, plenty of time for questions, because our, okay.
So I'm wondering what peers will initially be at this exchange point? What routes would be available for somebody who might be considering coming and peering?
I don't know that I have a complete answer to that, Dale, but certainly the UAE and all of the connectivity within the UAE, so any of the sites that are in there, and I don't have a complete list of who all those are, but certainly those. We would also be in a position to pull VLANs back through to Singapore, and anyone that is located within, for instance, Singaren or any of the Internet 2 co-location facilities. And as I said, there will also be direct paths from Singapore back to the U.S. That would allow us, again, to build layer 2 paths that would create...
Will Internet 2 routes be available?
I suspect the answer to that is yes. We'll have to kind of try this a little bit and experiment, but I don't see any reason why they wouldn't be available, no.
Hey, Dale, there was, at that POP in Fujairah, there's kind of a duty-free zone, and there was talk about trying to get permission for NRENs to pass through and not have to pay half-circuit costs to hit the exchange and then, you know, go further on. Were you successful in getting permission to do that?
To a degree, yes, we were. We've certainly gotten in a much better position than we started with. I'd be happy to kind of go over that at some other point in more detail, I think. But it's certainly a situation now that is workable. Yes.
Cool. Cool. So someone could come from Europe and just drop in there and hop out.
Yeah.
And without it being that expensive.
Yeah.
Awesome.
I think the answer to that is yes.
That's great.
Hey, Dale.
Hi, Andrew.
You mentioned Europe and Asia. What about Africa? There's a lot of cables that land in Djibouti, CUME 3 and 5. There's the Teams cable that goes
Right.
from Fujairah to
Right.
Kenya. So what do you think the impact on that
I would be
Africa will
delighted to have a conversation with any of the individuals who utilize those cables. And you want to?
Actually, we are welcoming both. Oh, sorry. I'm Fahim Naimi. I'm the CEO for the Ankabut, the UAE NREN. Actually, we are welcoming all Europe and Africa to join with us. And to answer to that question, we are already started a discussion with OpenNet to have African network to be connected there. And we start also discussing with Dante to have Europe connected to us. So yes, discussion already started, and inshallah we'll hope, as Dale said, it will be routing availability and we'll connect them. Thank you.
David West from GEONT. I'd just like to thank you for the AJOX presentation. Just to confirm from the European side that we are also interested in looking at the possibility of a connection from Europe to this exchange. Within the GEONT project, NA4 project did a survey 18 months ago which looked at remote campuses outside of Europe, and we found then that there was more European remote campuses in the Emirates than in any other country in the whole world. So we believe there should be a strong case for, which we're now trying to build, for justifying a link to Fujairah, in addition to the global architecture arguments that do also exist. If there's any European NRENs in this audience who are aware of universities in their country that have got a presence in the Gulf, particularly in the Emirates, but just in the Gulf, please do contact me, because we're very keen to work with you and to build the case for connection. Thank you.
So if we have no more questions, then we can go to our second presentation. Yves Pop will be presenting Infini Cortex. Yves has been working and contributed to the 100 gigabit connectivity with ANA 100, and most recently facilitated the first transatlantic 10 gigabit research and education connection. Was member of the Terrena General Assembly for more than a decade, and also represented TATA at Internet 2, Canary, APAN, and Glyph.
Thank you, Juan. History is being made here in Portugal at that Dirina meeting. I remember the discussions we had with Fahim years ago. It was still called Al-Hawarizmi Project, and JJ in the back there was involved too, and I'm really happy that it happens. Congratulations to all involved. It took more time than anticipated, but it's finally there, and we are very interested from an application point of view, because Carlos must know that we had discussions with the New York University in Abu Dhabi. In fact, Marek and I had the pleasure to be there at the inauguration of the new campus. Beautiful, worth visiting. And one of the projects we'd like to initiate, now that the connectivity will be there, is InfiniCortex between New York University in Abu Dhabi and Singapore. So that all to say, the sequence of my presentation has changed completely because events happen quite fast. So I will not take the floor too much. We made an important announcement, which is the NSCC, the new supercomputer center, and Marek Michalewicz is the CEO, and they will tell you all about it. Marek.
Good afternoon. It's a tremendous pleasure for me to be here. Thank you very much for giving this spot. And I don't want to take spotlight from Eve, who is absolutely instrumental in pulling this very ambitious and grand-scale project. But the project started in the context of preparation to create National Supercomputer Center in Singapore. I have been involved in this project for the last 6 years, and 2 days ago, and here's the date, 15th of June, while we already were here, the tender was awarded. And if you look at the sequence of dates, you will see that things in Singapore go very, very, very fast. And actually, we are on time. So, but let me go back now to the text of this slide. And I really want to emphasize something here in this group, that although personally my focus was always supercomputing, and then you have a community of people working network, as there were two different worlds. They're not different worlds. That's the same world. And for me, also, I would like to emphasize one thing, that whatever we create here in InfiniCortex is not merely to copy data and to use storage. Please think of InfiniCortex and network related to InfiniCortex, underlying fabric, as active part of this construct. And it's not only to move data, but also to allow RDMA and to treat distinct objects in this network as elements of concurrent, large-scale global supercomputing. And so we always considered in our plans on equal footing: computing, network, storage, service, software. And so as you see, we had in our plans, we put proposal for supercomputer, which on the sort of today's standard may be not very impressive, but that was not our point. Our point was not flops. Please bear it in mind. We could spec half much more, smaller storage, other elements, put hundreds and hundreds or thousands of GPUs. We could have maybe 10 times bigger computer. That was not the point. The point was to have extremely balanced system. And here are the most important things, that we want to have incredibly effective and easy access from at least 10 points in the island for commercial partners and for universities, provide this access from anywhere, support large data transfer, create big data system as well, and build local international network, not only as a physical network, but also as means to collaborate. And at that point, I have a fantastic opportunity to introduce few of the people. Remember that the project of this scope is not a project for 2-3 people. It's a project for dozens of different institutions. I'm very lucky to have 50% of my network staff of my center here. And please bear in mind, this project we pulled with 2 network staff. Please plus of course Eve, who is representing us and secures deals for capacity intercontinentally. But my 50% staff is here. I would like to introduce Joklen, please. So this is extremely hard working person. I also have with me Gabriel, who is on software, HPC software side. We have Andrew Howard, who represents Australia, but also works in designing architecture across the island. And we have David Southwell. David, please stand up, show yourself. And I hope that our talk will leave so many gaps and will be so sort of enticing to you that please approach those people and talk to them. Let me go to the next one. Where did I go? Here. Just to flash this through, because now I'm in a liberty to tell you that who won this very large contract. If you see this, the supercomputing part, including storage, is something like $35 million. Altogether, it's $45 million worth of project. And here are some elements of the system. What I want to indicate that we'll have one of the first large EDR connected cluster. Not the largest, but very interesting. What I want to stress is extremely high I/O and very large storage. Storage will be 10 petabytes. It's a very unusual ratio of storage to flops. So you'll see that we have definitely not focused on flops and Limpak. That was not our objective. And with this, I will just pass back to Eve to continue the talk.
Thank you, Marek. And in fact, I think one of the most original approaches in this project was the combination in one budget for the supercomputing part and the telecom part. Because very often it happens that the budget for one part is missing, and then it's, what do we do now? One reason for that is, of course, the insular nation of Singapore. Singapore wants to be a center of excellence, and Singapore needs connectivity to the outside world. And that connectivity includes, obviously, Europe, the US, Japan, which is important for us, and also the Middle East. So one has always to start at home, and we're building together with Singaren what will be the InfiniNet. We'll come back to the InfiniBand portion and the importance of InfiniBand in that whole equation. So there are a number of related initiatives. Marek, if you want to expand on some of them.
Right, we have been running this project at various stages, maybe since 2013, testing connectivity between our two campuses and also securing that we can have storage in a remote location. But out of that, immediately, to tell you one thing, within 1 week, we suddenly have new interaction, new project with MIT, with Institute of Systems Biology in Tokyo, and with few other partners. The number of new partners grows so fast, and the very valuable projects. Andrew was a witness of those new developments. So we will be using BGFC, which is a routing algorithm developed by Obsidian, and there are some other partners like TAC in Texas Supercomputer Center. We are working on InfiniCloud, which is provision of HPC-sized resources. So that means not a single server size, but if you want to have 100 or 200 servers interconnected with InfiniBand as an interconnect fabric, provisioned through InfiniBand over continental distances. That is possible, and Andrew is one of the creators of this technology. We are working now with Bright Cluster Manager, and if you have seen the recent announcements now, Bright is working also on object storage, so suddenly you have everything. You can provision over intercontinental distances, bare metal, with unified software environment and versioning of your compilers, operating system, and the like, and you can also have storage. We are working with the Institute of Systems Biology. We are working with DDR on infinite memory engines placed in different parts of the world, using also WOS. And we are working, the newest one is, of course, is Poznan and University of Reims and University of Lille, but I will leave it to Arthur to talk about this.
Thank you, Marek. So, InfiniCortex team, Marek introduced some of us. Now, the four elements which made this whole equation possible is very high-speed intercontinental transmission. And there I see Eric Jan sitting there. We were very proud when we introduced the first transatlantic 2.5 gig back in 2001. Before that, we were at 155 meg, but we will not go back too far when it was 34 meg. So that helps, and you will agree. Then InfiniBand over transoceanic distances. That was really something very surprising to me. I thought InfiniBand works only on a couple of kilometers until we discovered it also works on a couple of 1,000 kilometers, and we decided to try it out, and indeed it works. Third element is the galaxy of supercomputers, where we have an interconnect topology which Marek developed together with Yufeng Deng and Lukasz Orlowski, and basically it allows a concurrent functioning of multiple supercomputers. So multiple supercomputers really can function as one, which in turn could be a solution to a distributed exascale. And as you know, exascale is the holy grail of supercomputing nowadays. And obviously, if you don't have an application environment, all these things are totally useless. Now, to make this vision a reality, testing was done in Singapore. In fact, the initial testing was between two of our locations, Biopolis and Fusionopolis. Computing was in one location, and the storage in the other location, about 2 kilometers apart, and that was solved. Then we extended, and we tried with Japan. We tried with Australia, and with Australia, thanks to Andrew there, the results really became quite phenomenal. And everything was demonstrated at the Supercomputing 2014 last year. Last year, the demonstration was 100 gig. In fact, it was an emulation of what we did before, the year before on the Atlantic with the ANA 100. That was the circuit to Maastricht. Some of you certainly were there. And the year before that, there was Iceland to Europe. Where was it again, the Iceland circuit? From Reykjavik. Yeah, from Reykjavik. Yeah, to Amsterdam. That was the first 100 gig. So here, Tata provided kindly that 100 gig, and we had quite a number of demonstrations together with Oak Ridge and Georgia Tech and others. And it worked very well, and also Australia. And that Australian part was really instrumental in demonstrating the gain in effective throughput. So the application there, some of you must have attended the lightning talk given by Andrew this morning. Basically, you had gene sequencers in Australia, you had the supercomputing and the analysis in Singapore. The data was transmission back and forth. We're talking about 1.5 terabyte. So by traditional FTP, it would take around 24 hours. Using that InfiniBand, it was down to around 20-25 minutes. So the gain was quite spectacular. And we're proud to have received a number of awards in Singapore for these activities. This year, we plan to do more because now that the NSCC is announced, there are also two other parts to the project on the telecom side. We are working together with Dale and the Internet 2 to procure a 100 gigabit connection from Singapore to the US West Coast. Dale is in charge of the project and said he's making excellent project and progress. So it will be up and running. So then on the European side, we are working with tnc15, who has a tender out for a 10 gig to Europe, Singapore to Europe, because 100 gig is still unaffordable at this point in time. So these are the major points, and then also connectivity to Japan will probably be extended. Now, the whole idea is to grow a global InfiniNet, and we envision that we have an InfiniNet with Géant, as we would have with Internet 2. So basically the idea would be to have kind of a IB as a service. We were listening to Mignon earlier today in the Géant presentation of having different sets of services using our research infrastructure. This definitely is one, and one of great interest to our supercomputing community. And I'm happy to say that we really have demonstrated it the longest distance ever with Poznan, and I will invite Arthur to tell you all about this groundbreaking 30,000 kilometer long InfiniBand, and somehow it still works. And you can all see it downstairs.
Yves, thank you for the introduction. I promise that I am last guest here, invited by Yves. I have a pleasure to present you a result of our two research teams from ASTAR and from the PSNC, working since last supercomputing conference, where we agreed the first thesis of these tests, and how we could provide simulation, visualization across the long-haul InfiniBand. I would like to, using this opportunity, and thank you all partners involved in this project, because without their support it will be impossible to achieve this experiment. It means Obsidian, who provide equipment, and 6 operators, Singaren, Tata Communication, Pacific Wave, SNet, Jant, and Pioneer. Without these partners, it will be impossible, and great thanks to all of them. Of course, regarding a first thesis was that from the end user of supercomputers, we could define a lot of questions, and this question could be translated to the requirements of the system, how deliver efficient simulation and visualization to the end user. The end user, usually it is separated from the supercomputing, could make this kind of work remotely. That's result of this thesis is prepared by the COSCOS Grid. It is one of the EU-funded projects. It is implemented a middleware named Quality in Clouds and Grids, QCG, and this middleware allow you to achieve of this 4 important features. The first is provide set of the tools for the automatic control of the different types of the computation experiments in the HPC or the clouds. Clouds is still in the work of progress. They provide advanced reservation for the computing and the network. The second, it is the next feature, it is a progress monitoring and the notification for the end user, allow you to making a kind of the checkpointing of that. And the last, it is integration with the open source visualization tools as the ParaView that provide in situ visualization application. That's the result of this project. It is a kind of the approach tightly coupled. What it means that in traditional approach for the simulation and visualization is that the first you make a simulation, and after finishing the simulation you start to visualize this. Because some simulation it is a week or just some months duration, Here was proposed another approach, that some partial results could be sent to the visualization in this way that end user could control this. And if the simulation results are not going in the proper way, end user could do changes parameters. And is using a ParaView, this open source software for that. And we achieve this kind of the benefits as reduce waiting time for this graphical form of simulation. Second is that the dedicated HPC is using for the visualization and simulation, and we can use a kind of the tiny clients for the visualization. And I think one of the most important is a control and change simulation parameters on the fly. Regarding some of the workflow, we have 3 locations here, the TNC exhibition, the booth number 3, and the end user here located could start a simulation. It is a magneto-hydrodynamic software. It is a kind of the simulation of the turbulence and presented here. The next is starting visualization ParaView server in Poznań. The first simulation is starting in the Singapore, and as we have a partial results are sending to the Poznań, and via the remote desktop is presented here. That I would like to invite you to the booth number 3, and you can see a live result of this demo. Thank you very much.
Well, now, after this quite colorful and mixed presentation, we're ready for some questions. Well, I have one. It's probably not directly related to this. Is what is the role that you see of InfiniBand as you keep expanding the coverage? Do you see it as it will remain a specialized tool for connecting HPC centers, or do you see the potential for this technology to have a more broad role in the future of networking?
Yes, I think InfiniBand will not replace Ethernet, as some people who have worked for the last 20 years tweaking the most out of Ethernet and TCP/IP. They should not be afraid. InfiniBand will be in parallel. Now, the beauty of InfiniBand is the effective throughput, which is multiplied by a factor of 2, 4, 8, 12, up to 30. It all depends on circumstances. One application which came out of the blue was, as I mentioned, with Australia. The application was a genetic sequencer location A, supercomputer analysis in location B, far away from each other. So now for the first time, you can really separate geographically the sequencers and the supercomputers. Now it so happens that in the context of Ebola, Padre Sabetti from Harvard received from Illumina, which is a major supplier of genetic sequencers, a couple of machines to go and install in Sierra Leone and other places in West Africa. Now, would you not think that there is a transmission problem between these countries and here? Now, the Ebola virus has the bad habit of evolving quite rapidly, so it's quite important to have these sequences transmitted quite fast and have an interpretation. Now, everyone is talking about personalized medicine, so we need personalized networks to satisfy that personalized medicine. So that application domain by itself will already be happy to consume InfiniBand, unless, of course, you are very rich and bandwidth is not an issue for you. But even if that's the case, the instruments you have at the end are quite important. Another domain is very large baseline interferometry. If one thinks of the SKA project in Australia and South Africa, where you have exabytes of data per year. I think the faster you can transmit them, the faster you can read them and calculate and get some results. So InfiniBand is there to stay. Now, InfiniBand to the desktop, some people are dreaming about it, but I will be long retired by then.
Should I have this one? Okay. I may share with you there's a very large effort in China to incorporate InfiniBand to control electric grid in North China. And the InfiniBand allows you RDMA and also RDMA to embedded systems by passing operating system, which is very good for all sort of automation systems. And there are plans which we are aware of sort of in a maybe Big Brother style, have InfiniBand from data centers, between data centers, to utilities, to houses, to apartments, to appliances of normal citizens in China in a very big and substantial way. So InfiniBand has chance of dominating in some place, but how soon it will happen, I don't know.
Any question more? We are on time, so we have time for more. Well, then thank Yves and Marek and Arthur for the presentation. And we can go to our third speaker, Eric Bos. After working for more than 23 years at SurfNet, Eric Bos joined Nordnet in 2011 and in the Department of International Research Initiatives. Eric is a project leader of the Advanced North Atlantic Project, better known as ANA 10G, that created the world's first intercontinental 10 gigabit connection. He is also the co-chair of the Global Network Architecture Working Group, operating under the auspices of the Global Research and Education Network CEO Forum, that aims at creating a blueprint for the future network interconnect for research and education on a global scale.
Thank you, Joe. Welcome. I am very aware of the fact that my presentation is between you and the gala dinner, but I can assure you that my presentation is also between myself and my next flight, which is in a few hours from now. Okay, being the last speaker is always a pleasure, of course. You can wrap the topic up. I'm going to talk to you about federated operations in an intercontinental network environment. I will touch on 100 gig a lot. I'll build on the presentation by Dale and his guests and by Yves and his guests, and I have to apologize that I will not bring any guests. The outline of my talk is basically I will introduce very quickly NordUnet and, as Jou said, the CEO Forum. For those who have not heard about it before or want to learn more about it. Then I dive into the GNA, the Global Network Architecture, which is a project or a group of people that try to define a next generation blueprint for a global interconnect for RNE networks. Then I'll be more concrete on ANA, where we started, where we are now, and where we want to be. And then I dive into federated operations. And this picture is because it's about transport and big pipes. And as you saw in my previous slide, my opening slide, this is work that I do with Dale a lot. Dale and I work together a lot. We speak with each other every week at least. So any kudos from me, and the mistakes are Dale's, of course. Okay, let's dive into quickly NordUnet. We serve the 5 Nordic NRENs in Europe. That's a vast area, by the way. When I worked for SurfNet, as Jou introduced me, for 23 years, I thought anything above Hamburg in Germany, well, that's the 5 Nordic countries, densely populated countries, 5 countries. When you actually look at the area that NordUnet serves, it's quite big. One example is that if you would take Norway and would turn it around, you would end up south of Rome. So the 5 Nordic NRENs network a vast area. And when you look at the Nordinet booth downstairs, you see the network of the 5 Nordic NRENs, and you see that Uninet, the Norwegian NREN, goes all the way up to the top. And I have a pointer here, all the way to the top here, and even they have transmission going all the way to Spitsbergen, and they recently did a very cool project, I think, of Svalbard networking. Uninet created a resilient fiber path between 2 cities on Spitsbergen, and that is quite close to the North Pole. More polar bears than humans, and there's coal mining, there's tourism, but one of the major activities and the interest of Uninet, of course, is that there is research going on. There is a research station out there. Many countries, 25 or so I heard, of the world have permanent staff there that do research. So Uninet considered it its task to have good connectivity to the research station that is here in Ny-Alesund. So cool projects happening in the Nordics. And then, as I said, a few words on the Global RNE Network CEO Forum. This spun off from an idea of a few CEOs of NRENs sitting together at an Internet 2 Global Summit, or before it was called Global Summit. And they said, well, we meet each other at events like this, but we hardly spend any more time than a coffee break or a dinner together when we have time to talk about strategy, about what drives the NRENs of the world. So why don't we try to sit together more structured and more often? And out of that came the Global RNE Network CEO Forum, and it's modeled after the G20. The 19 influential economies of the world plus the European Union regularly meeting. And we right now have participants from Europe, North and South America, Africa and the Asia-Pacific region. And besides strategic dialogues, there are a few working groups that the CEO Forum guides on network stuff, middleware, and upper layer advanced services. And I would like to dive into one of these groups, which is called the Global Network Architecture Working Group. As Joe said, I'm the co-chair of, together with Jim Williams from Internet 2. Global connectivity today, you already in this session saw a number of pictures of networks. This is a rather recent picture of the APAN map. Lots of 10 gig connections. And I'm glad that Yves and Dale are working on extending that to 100 gig so they can enrich these maps. So lots of 10 gig connections. The well-known Géant map, networking seen from the European side, and the well-known Glyph map that needs an update because this is rather old, with lots of 10 gigs running all over the place. And if you would summarize all that connectivity, not every map has all the connectivity in there. And Mian Ousmane of Dante did quite a nice piece of work here and tried to summarize all these maps into one picture. You see how the bandwidth between continents is divided, which is quite unequal. There's some thick pipe here between North America and Europe. Well, the North Atlantic route is a well-supplied route, lots of competition happening on not so big a distance, only 7,000 kilometers. The Pacific Ocean, of course, is much bigger. Quite an interesting link here between East Asia and North America. But the rest of the links are quite small. So a lot of work needs to go into making sure that Africa and Latin America are, and Asia, of course, are much more integrated in the global RNE fabric. Well, the CEO Forum is not a money printing effort, of course. So the GNA work is divided technically into 2 pieces of work. There's one that I'm not going to talk about. It's about the narrative and making sure that we have a story for funders and agencies that we want to work with to increase the bandwidth available for RNE. And the other part of the work is making sure we have a blueprint, we have a story ready once we have possibilities to further upgrade this interconnectivity. So what is GNA? Well, let me zoom into the A of GNA. The G is global. Well, it's clear. We're working on a global endeavor. The N is network. It's all about networking, layer 3 and below. But the A, what are we trying to do? Are we trying to build a network? Well, no. The participants, I hope, will build the actual network. This group that now comes together regularly tries to define the well-agreed architecture of how it should look like, a blueprint. So it's a reference architecture, it's not a network. And it's an architecture, a blueprint to procure against and to build against. And there will not be one central NOC, one central facility that will collect all the money, do all the procurements, and run all the systems. That's not how the R&D network world works. We have regional networks, we have national networks, we have advanced networks, we have less advanced networks, developing networks. This is a collaborative or a federative environment that we're working in, and this is, in my view, the way we should continue. And this is a new paradigm for the way we approach intercontinental networking. Like if you go back many, many years, when the NREN started, you saw that, at least I can tell easily about the Netherlands, that's where I come from, that's where I live. Universities were, in the early 80s, end of 70s, trying to build networks between themselves. And that university, they worked together a lot. They built a link between them. And then there were two other universities starting to build a link. That creates spaghetti. I'm not saying that what we have out there right now is spaghetti. It's well coordinated, it's well tendered. But I think the NRENs as a global collective can do one step further at least and have more bandwidth for the same amount of money. So this is a rather old picture. There's a new version available on the website that I will point you to at the end of my presentation. But when we started this work, which is now 1.5 years ago, roughly, there was a white paper that had the initial thoughts of what we want to do. Say a 30,000 feet altitude view on a global network architecture. And this picture is taken from there. And basically what you see in here is 3 rings around the world. Again, in an artist impression, this is no way how we're going to build it. First of all, I think there should be a link between Africa and South America, for instance. And yesterday, or the day before, we heard from Michael Stanton from RMP already that there is opportunities coming up for building such a link. So again, this is an artist impression. And what you see in here are the red dots. The red dots are the things that Dale talked about, the open exchange points. In the blueprint we have created until now, in the work in progress until now, the open exchange points form a front and center network architecture element for how we think this architecture will and shall evolve. And then you see all kinds of signs, just depicted as some logos here that are, of course, sources and sinks of data. That's where important sources and sinks of data will be that we have to accommodate in the GNA blueprint. The fibers, the subsea fiber systems of the world are an important element, and many other things we consider important input for a well-agreed and a commonly agreed network architecture. There is a very high level, I've said 30,000 feet, architecture defined right now, and we're redefining that, or refining that, I should say. A physical network, that's where all the big pipes and all the open exchange points go. A substrate that yields, that comes from the big pipes and the open exchange points, and on top of that substrate we build overlay networks. That's basically at the very core of what we're doing right now. So this is all paperwork, this is theory, this is working sessions with whiteboards, this is video conferences at weird times of the day. We acknowledge the fact that we do need to have things in our hands that we can try the things that we talk about. So the concept of pathfinders for GNA has emerged, and one pathfinder for GNA is the Advanced North Atlantic Collaboration. Yves mentioned when the NRENs did 155 MAC, 2.5 MAC. Well, the first 10 gig, transoceanic 10 gig, happened in September 2001, when the iGrid 2001 conference was taking place in Amsterdam. 2 days before that conference, we finally got our 10 gig up and running before the conference. And it took us until 2 years ago to get away with that. What we have done in the meantime is add more 10 gigs to the mix. And you saw earlier in my presentation, you saw the maps of all the links running in parallel. Why is that? Why did it take so much time? Was there no demand? Yes, there was demand. We added more 10 gigs to the mix. But there were various other factors that influenced the fact that we could not make the next step to 40 gig or 100 gig. One of them was that 100 gig ultra long haul transmission took rather a long time to get ready. But once it was ready, we really wanted to embark on that. We saw it coming, we talked to the equipment vendors. And we defined the ANA 100 gig pilot. The first thought on that pilot were back in 2012. Basically, it was Dale and me and Rob Wietske and a few others that sat together and said, let's try this. Let's try to get the vendors, the equipment vendors and the carriers involved and see if they want to do a pilot with us. Well, fast forward through a lot of discussion and arm twisting and more arm twisting. And out of that came ANA 100 gig, a pilot with two commercial partners, a vendor, Sienna, and a carrier, Tata Telecommunications. We tried to say, okay, deliver a service to us. Well, no can do, because the marketing department, the product department did not have gone through all the hoops. So that was not a way forward, and Dante tried it, Indiana University tried it to do tenders, and what they got back was what we were fearing, 9 times the price of a 10 gig, roughly speaking. So that was not really an advantage to move into the 100 gig space. So finally, we, as you see here, Sienna and Tata, we embarked in a project that 2 years ago, and I gave a short presentation on that at the Maastricht TNC. We managed to do Manland to Netherlight, so New York City to Amsterdam, 100 gig pilot. This was a 7,000 kilometer single point of failure that we got to work in the end. And I just said 2 days before iGrid 2001, we got the 10 gig up and running. This was the night before TNC. We got the 100 gig up and running. So you need events like this to have a deadline to work against. 6 NRENs participated in this pilot: ESNet, NordGenet SurfNet, Internet2 Canary, and Géant. And these 6 NRENs were the driving force behind making this happen in time. I said there was no service possible, there was no reasonable price, there was no service that they could deliver, so we patched it together, so to speak. Two pieces of water here. Here's the 7,000 kilometer North Atlantic Ocean, and here's the North Sea between UK and Netherlands. What is it, 200 kilometers or so, 250 kilometers. We found out that, and all the color coding shows you who owns the box, who owns the line card, who owns the transponder. So we really patched it together in the best possible way we could, together with Tata and Sienna. The 7,000 kilometers was easily done. That came up quite quickly. Crossing the North Sea wasn't too bad. That came up quite quickly. And then to the show floor at TNC. I mean, here is Netherlight, and here we extended this to TNC to demo it. This was on SurfNet infrastructure. That was easy as well. The real culprit was here. The smallest piece of link that we had. This was another alien wave that we tried over Tata production infrastructure, and we tried to shoot an alien wave through the 100 gig. Well, that created quite a lot of delay. But we got that up and running just before the conference, and then we found out that resilience is key. 1 is 0. If you have 100 gig in your hand, you have no 100 gig in your hand. We knew this, of course, but we found out badly. The North Sea is quite a busy route for ships, and there's a lot of fishing going on. I mean, real fishing. And 3 times, I think, Dale, 3 times we lost the connection for 2-3 weeks because a ship dropped its anchor, dragged it along the sea floor, and cut the cable that the 100 gig was running on. And then you have to wait for the ship to arrive to repair. You have to wait for the weather to be better than it is. And then the ship can do its thing, and then repair it, and they have it up and running. So we said, what's next? The pilots stopped in October 2014, and 4 of the partners agreed to continue. And basically this has led to this, ANA 200 gig. And this time, of course, a ring, because we wanted to run production over this. And this is what is out there now. A 100 gig production ring, 2 independently routed 100 gig paths across the North Atlantic Ocean, open exchange points, these blobs here are open exchange points, and connectivity between the open exchange points on the continent. So if you zoom into it, this is Europe, Amsterdam, Netherlight, and Jean Open in London. A green one running on an Hibernia cable system, 100 gig between Amsterdam and New York, and a blue one, 100 gig running between London and Washington, between Jean Open in London and the Wix in Washington, on a Tata cable system. And then some 100 gig transmission in between to make sure that we have a system, we have a ring. And we took great care to make sure there's no single point of failure here. Because if you analyze this, it's easy to draw a diagram on a whiteboard. But if you analyze how the cable routing is, I'll give you one example. This Hibernia link comes in from Canada, from Halifax, Canada, into the UK here, in a city called Southport, very small city with an important cable landing station. Then it crosses the UK and goes into the Netherlands. Netherlands is a small country up here, and then there's a cable landing station 40 kilometers away from Amsterdam, the Zandvoort cable landing station. And it appeared that Norgenet and Surfnet run a fiber between Amsterdam and London that uses the same cable landing station. So that's not where you want to be. You have to go down to the details of fiber routing to make sure you have a fully resilient system. So we turned to a different solution, going south from Amsterdam on a Surfnet fiber that runs to Brussels, Paris, and Geneva. And that intersects with a fiber from Norgenet running from London through Brussels to Hamburg. And we made an optical cross-connect in Brussels. And we have done away with the single point of failure in Zandvoort. This is the other side, Wix and Manlan as the open exchange points, New York City and Washington. And Internet 2 is delivering a 100 gig lambda there to make the loop make the loop. So open exchange points are front and center of the ANA system. And it's big pipes and it's open exchange points. Like I said in the GNA piece of my presentation, this is about two important architecture elements. And this group of NRENs is now working on cost sharing. How do you share cost in a world where the pipes are so big that not one NREN is using that? We talk about joint engineering, and the remainder of my talk, federated operations. So, summary of the ANA today. Surfnet and Norgenet using it on the European side, and Canary and Internet 2 connected to it on the American side, on the North American side. And there is an important agreement we have with ESNet. Earlier today I saw the map of ESNet reaching out to Europe, and ESNet and the ANA partners agree that they will be each other's backup in case of failure. So ESNet is running 340 gig to Europe, between North America and Europe, and this system now is 200 gig. So that is, together, if you add it up and subtract the AUPs, you have 540 gig available for research and education. And recently, Jean procured 100 gig as well. And we are now working with Jean, Norgenet, Surfnet, Canary, and Internet 2 are working with Jean to make this into one big system. And then we call that ANA 300 gig. And the ambition that the steering group of ANA has put forward is 400 gig in the near future. Okay, last piece of my talk on federated operations. We have these big pipes and open exchange points. The participating NRENs hanging off the open exchange points. And how do you operate that? Well, we saw a few disasters in the ANA pilot, and we were lucky to have them. We were pointed to the weak spots in the ANA system, and we have now the aim, or we started the aim after the pilot ended, to define a workable and stable operations processes in an environment where the participating NRENs share the bandwidth. So there's a team headed by Dale. It's the operations group of ANA, and the 6 partners, the original 6 partners of the pilot, are collaborating in that. What we have defined in the federated operations model, and I think that's the cornerstone of the model we have right now, is that the open exchange points take the lead. These 100 gig links that run across the ocean, the Hibernia one and the Tata one, they terminate directly in the gear of the open exchange point. So there's no gear, no routers, no switches in between of the participating NRENs that have procured the links. The NRENs hang off the open exchange points. So in a very simple next mind step, it is the open exchange points that look and feel, that see and feel how the physical pipes are working. Only from the NREN you can verify that. But if there is an interface up-down, there's flaps on the interface, the open exchange point will notice that. So we have put the 4 open exchange points in this pathfinder for GNA in the front and in the center of the operations. So MANLAN, WIX operations under the auspices of Internet 2, done by Indiana University, Netherlight operations at SurfNet, NOC, and Xi'an Open operations done by the Xi'an NOC, are the ones that look after the ANA infrastructure. And let me dig out one example here. The 100 gig on the northern route between Amsterdam and New York that touches Canada and the UK. It's a 100 gig clear channel lambda. It has endpoints in Amsterdam and New York, and the supplier is Hibernia. But there's a contract signed, and the contract is signed on behalf of the consortium of ANA with Norginet. So one step back, Norginet did the tender, out of that came Hibernia as the best offer, and Norginet and Hibernia signed the contract. Operations of this link is done by Netherlight, that is SurfNet, and MANLAN, that is Internet 2, NOC at Indiana. So Norginet has no direct operational role in the running of a circuit that they have procured. And that is a mind step that, well, people needed to get used to a little. NRENs are very used to, I procure a link for 1 year, 2 years, 3 years, and I take the lead in running that link. Here it's a shared or a federated operations endeavor. So it's running production since January this year, and so far we have learned a lot, been able to sharpen the processes, and I think it's running wonderfully well. We have seen outages. We have seen outages on the transatlantic 100 gigs, and we saw that it was noticed by the NOCs, and we saw that the traffic rerouting that we engineered really happened quickly without anybody, without the users knowing. So I think we're on the right trajectory here, and we're going to test this further, and we're going to, I hope in the next session, update you on what we have found. We are refining the processes right now. We are filling the Rocky tables and all the stuff that you have to do when you do operations right. Next step is we're defining open statistics. What are we going to ask from the open exchange point operators to publish? Well, port statistics should be general available, we think. The complete traffic through the switch, the part of ANA on the switch, should be generally available. Opt-out possible, we discussed that earlier this week here in Porto when we sat together with a few folks. Net flow data, if you are able to collect it at all, should of course not be available, should not be made available due to privacy reasons. By the way, in the Netherlands it's illegal to do deep packet inspection, so you don't even want to go there. And we're further fine-tuning the processes. So, Joe, this brings me to the end of my presentation. And I hope we have some time for questions and answers.
Any questions? I will have one.
There's just one question.
Okay.
Thanks for your presentation, Eric. Can you tell me, this is a great proof of concept, but is there any traffic actually flowing over this network? And if so, what are the applications?
Yes, there is traffic. Dale, you want to comment on that?
At this point, there's probably on average about 20% of utilization on the links. And we are in process of bringing up more peers across it over the course of the next week and a half. And, I anticipate we'll get up into the 30-35% range through the course of the summer. And, of course, in these sorts of links, part of what you want to do is leave a good deal of overhead. You certainly don't want these things running. If we get them to 60%, somebody's going to have to spend a fair bit of money to get another one. Well, I think that's a good idea. Not everybody does. I mean.
To add to what Dale just said and to answer your question, Alex, I approach it from a more technical point of view, but if you approach it from a money point of view, what we saw inside Norginet, and I will talk about Norginet only. Before we embarked on ANA 200 gig, we had 2 10 gigs running across the Atlantic, and the traffic levels were such we badly needed a third one. So in the summer, end of summer 2014, we decided, what are we going to do? Are we going to wait for ANA 200 gig, or are we going to buy ourselves a third 10 gig? And then we looked at the tendering and the pricing that came out of the tender, and it was clear that 3 times a 10 gig right now, roughly speaking, is equal to the price of 100 gig across the North Atlantic Ocean. So money-wise, Norgenet is now spending what we plan to spend on 30 gig we thought initially, and in sharing bandwidth as we do now, we have 200 gig shared available to us in a resilient way. So, and we did away with the 2 10 gigs, by the way.
And just to elaborate a little bit more, one of the really interesting features of the reference architecture is something that we internally sort of think of as the commons, which is a part of the bandwidth that is not guaranteed to any particular user, but is available to people who want to do interesting things across high-speed links that go a long way. And as I said, keeping that kind of capacity available is very important in terms of the architectural design that we have in mind for these circuits and similar systems.
This is the URL I promised you. The work of the GNA is now online. A month ago we launched a new website, or is it 2 months ago already? It's gna-re.net. We solicit your input, you solicit your participation in this, but also we create a few white papers, slide decks that are all on there. So if you want to learn more about what Dale just said about the commons, please go and look there. It's there already, or it will be soon up as we are preparing a new version of the document that defines the GNA as we think is current today.
Also, a question regarding this part of your presentation is that in one of the pictures that you showed in the beginning, there was no Africa, no Latin America. So is there any news or plans to bring these 2 regions to the global network architecture of the open exchanges? It is true that, or at least it's in the news already, the South-South cable between Africa and Latin America, at least it's being announced. So there are new cables coming to this region, and so is there any news that you are aware of having open exchanges in these regions?
Well, thank you for asking this question, Joe. I mean, I talked about ANA as a pathfinder for GNA. We are working with the project called M-Light that is driven by RMP in Brazil and Florida International University, AMPATH in Miami. They are aiming at creating a 100 gig circuit, 100 gig service between the US and Brazil. And then the plan is to glue that into ANA and somehow close the air gap between Miami and Washington and New York, to also enable 100 gig transmission from Brazil into Europe. RMP runs already open exchange points in Brazil, and we have been talking to RMP when the cable from Fortaleza in Brazil comes to Portugal, comes to Angola in Africa, that these are excellent paths to explore further with WECRAN, with Europe, to ensure that we can create bigger rings around the Atlantic Ocean. And in my dreams, I see not a triangle across the North Atlantic Ocean, but I see a ring around the full Atlantic Ocean, going from North America to South America to Africa, and then back to Europe, and then close the loop like that.
So a lot of things to happen in the next 1 or 2 years.
We talked to WECRAN, we talked to UbuntuNet Alliance, and we very much would like to have their input on what we should do for Africa in this.
Any more questions? Well then, having 6 speakers instead of 3, and we managed to terminate on time, so it's really a good thing. Thank you, everybody. I should thank you.